And good morning. We're going to go ahead and do lesson 3.2 now. So this will be on page, I think, 61 or something like that in your book. All right, so in order to really work with unknowns, we have to grasp the concept of equality. While this is a concept you've been using for years, we're going to dig a little deeper into it. All right, so as I'm sure you already know, an equal sign indicates that the quantities on both sides of the sign are equal. Here we have an equal sign. Both sides are equal. That's simple enough. All right, let's move to the next page if my computer would be so kind as to load it and not act funny. Okay. Well, for some reason we're skipping a page. There's this. Here we go. Yeah, I'm not so sure what's going on with my computer. If we add a quantity to one side, then we'd have to add the same quantity to the other side in order for the equation to stay equal. So if you add 2 to this side, you must add 2 to this side. So long as we add the same quantity to both sides, the sides remain equal. Likewise, notice if we subtract the same quantity from both sides of an equation, the sides stay equal. Subtracted 2 from both sides, you're equal on both sides, you still have 4. Okay? When we multiply or divide both sides of an equation by the same quantity, the sides again stay equal. This one was multiplied by 2. You have to do it on both sides. Divided by 2, both sides. In short, an equal sign means that both sides are equal or in balance. So if we perform the same operation using the same quantity for both sides, the sides will still be equal. Now, not only can you add, subtract, multiply, or divide both sides of an equation by the same quantity without affecting the equality of the sides, you can also swap the entire left side of the equation with the entire right side of the equation. Next page. Why? Because equal means equal. Since we swapped the entire sides, we didn't affect the equality of them. So notice, here's you some examples. 6 plus 2 equals 8, and they've swapped it around. 8 equals 6 plus 2. They've only swapped them. Same thing here. 6 minus 2 equals 4, and 4 equals 6 minus 2. Doesn't matter how you do it. 2 divided by 6 equals 12, and 12 equals 2 divided by 6. I said divided by. I meant times. I don't know why I said that. This is divided by. 6 divided by 3 equals 2, and 6 divided by 2 equals 6 divided by 3. Now, here's an important note. When swapping the sides of an equation, we're moving the entire expression from one side to the other. We're not changing anything about the expression itself. For example, in 6 divided by 3 equals 2, we can switch the 6 divided by 3 to the right side. But we would be changing the value if in the process we changed the order of 6 divided by 3 to 3 divided by 6. We have to move the entire expression without changing the order. 6 divided by 3 does not mean the same as 3 divided by 6. 6 divided by 3 equals 2, but 2 equals 3 does not equal 3 divided by 6. Remember that. Now, of course, addition and multiplication are commutative and associative. So if all we had was addition or all we had was multiplication on one side of the equation, you can switch the order without changing that value. See, 6 plus 2 equals 8 and 2 plus 6 equals 8. And 8 equals 6 plus 2 and 8 equals 2 plus 6. And same thing with multiplication. Those two, you can change the orders and it doesn't matter because they are commutative and associative. Be careful though. Only switch the order if you know you can because of a property. Otherwise, you'll end up changing the value of the expression. So it's safest to develop the habit of swapping entire expressions and then only break from that if you know you can without changing the value of the expression. Now, you may be a little bit confused. You may not be, but you may be thinking, okay, this is dumb, this is elementary. But there's a reason why we're starting here now. Now, why do we care that quantities are equal? I'm glad you asked. One of the key things we do in math is look at how quantities relate. That is, at the relationship between them. Many of these relationships can be expressed as an equality. For example, a symbolic expression of the fact that two quantities are equal, an equation. For example, A equals L, this is supposed to be an L times W, expresses the relationship between the area, length, and width of a rectangle. The equal sign lets us know the area equals the length times the width. So when you solve word problems, you use equalities to express relationships. For example, the total money you have left after an event will equal the money you started with plus any money you were given minus any money you spent. Okay, next page. So your ending money would equal the beginning money plus money gained minus money spent. And then you could use letters to represent that to even make it easier. Now, understanding equalities is going to help us better understand how to work with many real-life relationships. In fact, in the next lesson, we'll begin using the principle of equality to help us solve problems containing unknowns. All right, now, all of this right here is just simply giving us the perspective of how God's faithfulness is to keep things consistent. In 2 Thessalonians 3:3, that the Lord is faithful, who shall establish you and keep you from evil. Okay, there we are. All right, so now let's look then at our worksheet. Worksheet 3.2, and there's 2 pages to it, but like the last lesson, it's pretty easy. Okay, on part 1, equality. Insert the equal sign in between equal quantities or expressions and the does not equal sign, which is this, between unequal quantities or expressions. For instance, let's take, this one. Does 8 equal 8? Yes, it does. So you'll put equal here. All right, look at B. Does 8 plus 2 equal 8 plus 2? Yes, it does. So you'll put an equal sign there. Okay, right down here, let's look at E. Does 8 divided by 2 equal 8? It does not, because this would be 4 and this is 8. So you would put the does not equal sign between, which is this. It's the equal sign with a line through it. Okay? So if you want to go ahead and pause it right quick and finish that section, turn it back on, we'll go over each little section. Okay, so on part 2, this is swapping sides. We're just going to rewrite each equation so that the entire left side is on the right side and vice versa. So here's an example. They're giving you 47 minus 5 equals 42. Your answer then would be to change it around. 42 equals 47 minus 5. Remember, make sure that you keep it to where it does equal. Okay, so go ahead and pause it as you do those 4. Okay, so on 3, the finding the unknowns, list the value for x that would make these equations true. So these two are the same as what we did kind of on the other. Make sure you read the example meaning and go ahead and put x equals and whatever it equals. And if it's money, make sure you put the dollar sign. If it's whatever, make sure you put what it is. Okay, so go ahead and pause that as you do these 2. All right, so on these, representing relationships, remember to consult the reference sheets, pages 423 to 428 if you need it. In the back of your book, it gives you those formulas, and I think that's what they're wanting you to use if you need it. Okay, in C equals 2 times pi times r, which is finding the circumference of a circle. What does r stand for? Stands for radius. Remember, this stands for circumference equals 2 times this symbol stands for 3.14 times r, which stands for radius. So your answer on this one is radius. All right, on B, look back at the general instructions on page 421. What value should you use for this symbol in this course. You shouldn't have to look back. The value that you use for this, that this symbol stands for, is 3.14. So anytime you see this value, this is kind of the same thing we've been talking about. We just introduced it in book 2. 3.14. This is pi, and it stands for 3.14. And then that number stands for the relationship between the circumference and the diameter of a circle. So, all right, now on this one, find the circumference of a circle with a radius of 8 feet. So what you would do on this one is you're going to take this back here on this page we just did. You're going to take this, well, come on computer. Well, it's going to freeze. Here we go. You're going to take this formula right here, C equals 2 times pi times r, and you're going to write that formula, C equals 2 times pi times r, and you're going to fill in the numbers. Now, let me see if I can just kind of do this one with you. Now, when I was in school, my teacher always made me, you had to start with the formula, and you had to have every single step, and if you didn't have it on there, you'd get points taken off. So first we're going to write our formula, C equals, oh my computer, I'm so sorry. It must be getting old. Well, it's not going to let me write it. Oh. Here we are. Okay, well, I'm not going to bother you anymore, little computer. Anyway, you'll write the formula out and then fill your numbers in and rewrite the formula with your numbers in there. And then when you get to the end, you should have C equals and what it equals. Okay? Now, and then you'll want to find the area of the circle, the formula for that in the back of your book. And then, of course, you'll do the same thing here. All right? Now, go ahead and pause it as you finish those, and then I'll help you with F. Okay, so on F, it should be really easy. It just gives you, it's kind of the same thing that we had in one of our examples when we were reading. If the total cost to attend an event consists of the ticket price plus the food price, use letters to show the relationship between the total cost, the ticket price, and the food price. You can use whatever letters you like. So go ahead and pause it right quick while you write an equation for this. You're not solving anything, there's nothing to solve, but you're writing an equation using letters, any letters that you want to. So pause it while you do this. Okay, so you should have something to the effect of T. I'm afraid to write because my computer had a fit. Okay, so T, and you can use any letter, but this is how it should have been. So T, which would equal the total cost to attend the event, and then the rest of it would be equals P, which would be the price of the ticket, plus F, or whatever you wanted to use for food. That should be what you have written something to that effect. You could use any letter as long as you have something here equals something plus something. That would be your equation. Okay, now on 5, okay, let us do, these are miscellaneous. Okay, I think on A through D you should know those. These are ones that we've been going over. On letter E, solve using the distributive property showing your work. Now what you're going to do on this one is, on the distributive property, you distribute out the answer. So basically you would have this. You would have 2 times 10. I'm using parentheses here. Okay, because this is 2 times 10, okay? Then you're going to have plus, and then you're going to have 2 times 3. See how I'm distributing it out? That word is hard to say sometimes, distributing, okay? Then we're going to have our plus distributing this out, and then we're going to have 2 times 1/4. Now there's our equation distributed out. Now, obviously it's not your answer, so you're going to get your answer and bring them down. And then finish the equation. 2 times 10 then would be 20 plus 2 times 3 is 6 plus, now 2 times 1/4, remember 2 over 1 is 2, times 1 over 4 gives us 2/4. And do you know what 2/4 simplifies to? Half. Why does my plus look like that? Plus half. All right. So then your answer is going to be 20 plus 6, which is 26 and a half. Now, this should not be your final answer. You should have it all written out like this. So anytime it says to show your work, make sure you do show it somewhere. Let me know that you did understand how to do the distributive property. Okay? Now I'm going to leave you with A, B, C, and D. These are things that we've been going over the past couple of chapters. So if you need any help on any of it, just let me know. And I'm not going to grade these pages, but I do want to see them, okay? All right, that's all for today.